we want to prove that if x squared minus 3x plus 2 is less than 0, then x must lie between 1 and 2. There are other ways other than contradiction of doing this question, but we'll do proof by contradiction. And we're going to do this in two parts. We're going to start off by assuming that x is less than or equal to 1, and then we're going to assume that x is bigger than or equal to 2. So let's assume x is less than or equal to 1 to start with. So we're going to let x equal 1 minus k. K is a real number, but bigger than 0, yeah, which always then makes x less than or equal to 1. So if we then substitute for x in our given inequality at the top, we end up with 1 minus k squared minus 3 lots of 1 minus k plus 2. And this is going to be equal to 1 minus 2k plus k squared minus 3 plus 3k plus 2. And if we simplify this, this gives us k squared plus k. Now, k squared is squared, so this is always going to be positive. We said in our assumption here that k is bigger than 0, so k squared is positive, k is positive, so we have here an expression that's always bigger than 0, but we want this to be less than 0, therefore we have a contradiction, and we can assume that x must be bigger than 1. Part 2 in the same way. This time we're assuming that x is bigger than or equal to 2. So again, we're going to let x equal 2 plus k, and again k is a real number that is bigger than 0, so we're always going to get a number that's bigger than 2 coming out of this one. And again, we're going to substitute 2 plus k into the original inequality. So we've got 2 plus k squared minus 3 lots of 2 plus k plus 2. And this is going to give us 4 plus 4k plus k squared minus 6 minus 3k plus 2. And if we collect our like terms together here, again we end up with k squared plus k, and we can draw the same conclusion. K squared plus k is always bigger than 0, therefore we have a contradiction. X must be less than 2. So finally, to finish off, we conclude that if x squared minus 3x plus 2 is less than 0, then x must be between 1 and 2.